Hello and welcome to this episode where we shall be looking at the preparatory examination for Gauteng Province 2022 Mathematics Paper 1. All right, so the paper was a full paper, which was 150 marks. And the instructions, we have 11 questions. All must be answered. And then question number 1, which is the usual algebra. They want us to solve for x. Okay, so when you look at 1.1.1, it's a dot product where we have 2x times this bracket must give us a 0. So from our dot product, we clearly know that if we have a times c is equal to 0, it's either the a is a 0 or the c will be a 0. So we don't need to open this up. Just apply the dot product. So what I'm going to say, I'll put the 2x and equate it to 0, or I'll have the x squared minus 1 must give me a 0. So from the first approach, we can divide both sides by 2. Clearly, x is going to be a 0. And from this second bracket, I can see it's a difference of 2 squares. So I can say x minus 1, and then x plus 1 should give me a 0. So which means either x is a 1 or x is also negative 1. In other words, we have 3 solutions for this question. Because if you were to open this up, we're going to get 2x cubed. And degree 3 must always give us 3 solutions. Then 1.1.2, we have x minus 6 plus 2 over x is equal to 0, but x can never be 0. We want it to correct to decimal places. So remember we said whenever a question comes with this condition, we're going to apply the quadratic formula. But before we apply the quadratic formula, we have to make sure that this whole thing is in the standard form of the x squared plus bx plus c. All right. So I'll say if I have my x minus 6 plus 2 over x is equal to 0. So step number 1, I'll get rid of this denominator or try to eliminate it. And the only way for me to do that is if I multiply through by x on both sides of the equal signs. So if that is times x, times x, times x, and then times x. So this x and that will cancel. I'll be left with x squared minus 6x plus 2 is equal to 0. So this is the standard form that we must use. So from this, we know that our a is a 1, our b is a negative 6, and then our c is a positive 2. Then from the quadratic formula where we have negative b plus minus square root of b squared minus 4ac, we're dividing this by 2a. We just do the substitution. So our b shall have a negative and negative 6 plus minus b squared. We're going to say negative 6 squared minus 4. Our a, we say it is a 1. Our c is a 2. Dividing all this by 2 times 1. Okay. So remember, when you're punching this into the calculator, when it comes to the signs, you use one sign at a time. Okay. So if I put this into the calculator, my first x value I'm getting is 5.65 if I'm to round it off to just 2 decimals. Then the second, if I use the subtraction, I'm getting 0.35. That is if I'm to round it off to 2 decimals. All right, so that is what we do, what we get. Normally we want 2 decimals. So if you give more than 2 or less than 2, you might be penalized for the rounding because the instruction is clear. It must be 2 decimal places. Okay, so we said it's 5.65 or 0.35 to 2 decimal places. All right, then 1.1.3, This is an inequality. So they're telling us if we have x minus 1 times x plus 4 is greater or equal to 6. So we cannot apply the rule that we used in the first one, since we do not have a 0 by the right-hand side. So we just need to open this up and create a standard form. So I'll do it on this side. Okay, so I will have just create space there. Okay, so we're calling that 1.1.3. So we're saying x minus 1 into x plus 4 is greater or equal to 6. Okay, let's open this by using the FOIL. Okay, so x and x is going to give us x squared. That's going to give us a 4x. This and that is a minus x. This and that is minus 4. Then we need to pull this 6 that side. Minus 6 is greater or equal to 0. When I simplify this to create my standard form, I'm going to have x squared plus 3x. This and that is going to give me a minus 10 is greater or equal to 0. Then I can use my dots here, or I can use the quadratic formula just to solve for this. So if I use my product, my factors, numbers I multiply to give me negative 10, I add them to give me a 3. I'll have x probably in 5, x with a 2. Since the sum is positive, I'll put the 5 there, and I'll put the negative there. Is greater or equal to 2. Okay. Then I need to get what we call the critical values, or what would be solutions. So we're going to have x as a negative 5, or x is going to be a positive 2. Now, how do we represent this? Because I've seen a number of learners just saying x is equal to negative 5 and x is equal to positive 2. That is kind of wrong, because we are dealing with inequality symbols, so you must give the solutions with this. So if the inequality is greater or equal to, then in most cases, our solution is going to be x is less than the smaller number, and then x must be greater or equal to the bigger value. That is how we represent the solution, for as long as the inequality is greater or equal to. If the inequality was less or equal to, then it could be the small value is less or equal to the x, less or equal to the big value, something of the sort. So in this case, we're going to say x must be less or equal to negative 2, or x must be greater or equal to positive 2. So this is how you would represent it. Alternatively, someone would draw a graph or a line, number line, and draw the parabola. Okay, so that is 1.1.3. Then I'll move on to the next page. That is question 1.1.4. So we said x is greater or equal to 2, then x is less or equal to negative 5. All right, so 1.1.4, so we have the square root. We have the roots, okay? So square root of x minus 2 plus a 3 is equal to 10 over square root of x minus 2. Okay. How do we go about this? Okay, so there are two ways that I can see. It's either we can multiply through by the root sign throughout. Okay, so that we have, let's say, square root of x minus 2. We're gonna multiply it by root x minus 2 plus 3 times root x minus 2 is equal to 10. Because when you say 10 over x minus 2 times root x minus 2, these two will cancel out. That is alternative number 1. And then the second alternative, since we know that this is the same as that, someone can let this be a letter. Maybe if we call it a t, so that it is t plus 3 is equal to 10 over t. And then we just solve for t. And then later on, we just replace t with this kind of expression. Okay, so I'll try with the first one. Okay. I'll try with the first one and we'll see what it gives us. So we're saying that this is 1.1.4 square root of x minus 2 plus 3 is equal to 10 over square root of x minus 2. So we said multiply through by square root. So we're going to have x minus 2 times the root of x minus 2 plus 3 the root of x minus 2. We say this is just going to give us a 10. From our sides in the previous grade, we know that root a times the root of a must just give us a, since that's going to be square root of a squared, which is the same as n. Now, when I look at these two brackets, so it means I'm just going to have x minus 2 as my final result here. And then plus 3 with the root of x minus 2 is equal to 10. Then I'm going to move everything to the right-hand side and leave the root sign alone. So I'll take the 2 and the x that side. So when this 2 moves that side, it's going to make it a 12. So I'm going to have 3 square root of x minus 2 is equal to, we said 10 plus 2, that's going to be a 12. And then we subtract x. Okay. Then from here, we can square root both sides. We can square both sides. So this squared, and then that squared, so that we can get rid of the root sign. Now, for as long as we have a number in front of the root sign, that number is also going to be affected by this square. So 3 squared is going to give us a 9. Into the root sign is going to fall away. So this only applies if we are multiplying by the root or we are dividing by the root. We cannot square if we have addition there. It will complicate life. So that's going to be x minus 2 is equal to, when we open this up, it's going to be 12 minus x and then 12 minus x. Okay. So when I FOIL that, I'm going to have 144 minus 24x plus x squared. Open the left-hand side, it's going to be 9x minus 18 is equal to 144 minus 24x plus x squared. And then I'll just create a standard form. Okay, I'll move the 9x to that side, the 18 to that side. So I'll have x squared minus 24 minus 9. Okay, negative 24 minus 9, I'm going to have negative 33x. And then 144 plus 18, I'm getting 162 positive is equal to 0. Okay, then from here, I can choose to use my either quadratic formula or what's that thing, or just the factors. So if I look at the factors, which numbers do I multiply to give me 162 positive, but then when I add them, I end up with a negative 5. So this would be, which numbers are those? 33. We have some 162 divided by 33 is going to give me, no, that's something else. So if I try 7 and 6, you can use the quadratic formula just to save time. Okay. So that's going to be x minus 27. Does it make sense? Yes. And then x minus 6 is equal to 0. So either x is going to be a positive 27 or x is going to be a positive 6. Then we have to test the values. Okay, we need to test. Whenever a question of a square root comes, you need to test your answers before you get to the conclusion. So if I'm to write down the original statement, which was square root of x minus 2, plus a 3 plus 10 over square root of x minus 2. Okay, so how do we test? We just have to replace these numbers, the x values on the left-hand side, and see if we're going to get the same thing on the right-hand side, or the same result. So an example, if I use 27, it's going to be 27 minus 2. If I'm looking at the left-hand side, 27 minus 2, that's 25. Square root of 25 is 5. And then 5 plus 3 is going to give me 8. That's in the left. On the right-hand side, I have 27 minus 2, which is 25. Square root of 25 is 5. I have 10 over 5, which gives me a 2. So on my left, I'm having 8. On my right, I'm having 2. So that solution it's not working out. In other words, what I'm getting on the left is not the same as what I'm getting on the right. So we cancel that solution out, or we simply say not applicable. Okay. Then let's try 6. If we have 6 minus 2 on the left-hand side, it's going to give us 4. Square root of 4 is 2. And then 2 plus 3 is a 5. We're saying square root of 6 minus 2 plus 3, which is a 5. Let's look at the right-hand side. With the right-hand side, we know that 10 divided by square root of 6 minus 2 is a 4. Square root of 4 is 2. 10 over 2 gives us a 5. So since we have a 5 on the left and 5 on the right, this solution stands and will still remain as the correct solution for this question. Okay, so that was alternative number 1. Remember, alternative number 2, we said you can just replace the square root into the letter format and then solve. It could be a little bit quicker. Okay, then 1.2, they want us to solve for x and y. We have x minus 2y is equal to 1, and then we have this. So what we say always is look for the linear equation. If you call this equation number 1, you call this equation number 2. From the linear equation, we can manipulate the x if we move the y that side. So we're going to have x is equal to, I'm going to say 2y plus 1, or 1 plus 2y. Then I'm going to call this equation star, or I'll call it equation number 3. And then I need to substitute this equation star into equation number 2. Where I see x, I'll replace it with all of that. All right, let's do that. So that is 1.2. So we said x is 2y plus 1. And then our equation number 2 is x squared. It's 2x squared. So 2x squared minus xy, okay, minus 5y minus 3y squared is equal to 0. Okay, so we said where there is x, we're putting the whole of that. So we're saying substitute, say this is star, equation star into equation number 2. Okay, so that's going to be 2 into 2y plus 1. I square that minus my y. I'll put the y first, and then I'll have 2y plus 1, this x. I need to replace it with this whole thing. And then I'm subtracting 5y, I'm subtracting 3y squared, and equating it to 0. So then I'm going to open the square bracket, the first one. You can still use the off-whale. So I'll keep the 2 for now. I open that, I'll have 4y squared plus 4y plus 1 minus, that's going to be 2y squared. This with negative y and the 1 will give us negative y. Minus 5y minus 3y squared is equal to 0. Let's open this bracket. 8y squared plus 8y plus 1 minus 2y squared. You can simplify this if you want. 6y minus 3y squared is equal to 0. Then I'll do my final simplification by collecting the like terms. This is 8 minus 2. That's a 6 minus 3. I'll be left with 3y squared. Then I have 8y minus 2 minus 6y. That's going to give me a 2y. And then I'm just going to be left with a 1 as a constant. Does it make sense though? Or did I do something wrong? Okay, I'll go revisit and see what I did wrong. Let me just confirm the equation. Oh, there's something I left out. This minus 2. I left the minus 2 out here. So we said minus 2. That's minus 2. And even my opening here is wrong. So we're going to say this is a plus 2. But this is wrong. So if I have a minus 2 here, and this, that's going to die out. Okay. Then that is a 0. But it's not making sense. Okay. Then we just open up, take out the y. We're going to have, let's say, 3y plus 2 is equal to 0. Then either y will be 0, or I'll equate this to 0, which means my y is going to be negative 2 over 3. Okay, if I say 3y plus 2 is 0, move the to that side, divide both sides by 3. Then I'll get this and then substitute into my equation star for me to get my x. So if the y is 0, then my x is just going to be 1, because 2 times 0 plus 1 will be 1. And then if my y is negative 2 over 3, then now x is going to be 2 times negative 2 over 3, and then plus a 1. So which means our x will end up being, that's negative 4 over 3. It's going to be a negative 1 over 3. Okay, guys, so those are the solutions for the simultaneous. All right. Then we'll move on to the next question. Move on to the next question, and that is 1.3. 1.3 is to do with exponents. 2 to the x plus 1 plus 2 to the x is equal to 3 to the y plus 2 minus 3 to the y. Okay. So what I'm going to do here, on my left, I have just 2's, and then on my right, I have 3's. Is it possible for me to expand? Yes. And if I have plus signs and minus signs, which means I can factorize out at some point. Okay. So I'm going to start by expanding this. We know that 2 to the x plus 1 is the same as 2 to the x times 2. Then I'm saying plus 2 to the x. On my right-hand side, 3 to the y plus 2 is the same as 3 squared, and then 3 to the y. Because from the laws of exponents, when you multiply numbers with the same basis, we add up the exponents. So I'm going to say minus 3 to the y. Then I can factorize out. Let's say 2 to the x comes out. I'll be just left with 2 plus a 1. Okay. And then on my right-hand side, 3 to the y is common. I'll be left with 3 squared minus 1. It's fine. I'll just do that. Then if I look at, it's fine. I'll just use this space here. So when I simplify my left-hand side, I'll have 2 to the x times 3. And then that's going to be 3 to the y into 3 squared is a 9 minus 1. That is 8. Okay. So in this case, I can decide to use the same bases or something like that. Alternatively, if I keep the x's and the y's on the same side, then I'll keep the numbers on the other side. which will still give me more or less the same thing. Okay, where I'm heading to is if I look on my left hand side, this is 2 to the x. When I look at the right hand side, I can match this with the 8, since I can also express 8 with a base of 2, which is 2 cubed. When I look at my left, 3 to the y, I can link it to this 3, since it's also having a base of 3 with an exponent of invisible 1. So I can use this root and just conclude that 2 to the x is the same as 2 to the 3, or the 8. And then which means x is going to be a 3. So we know that if the bases are the same, then even the exponents will be the same. Same story, 3 to the y is going to be equal to 3, and then I will equate the exponents. So y is a 1. Getting x as a 3, and then I'm having my y as a 1. This would be my approach. I don't know. Someone could also just divide so that you leave the variables on one side. In other words, that would be 2 to the x over 3 to the y. That's going to be 8, probably over 3. And then you treat the top numbers separately, and then the bottom numbers also separately. That's what I just did. Okay. Then 1.4. 1.4, they're telling us that the equations x squared plus rx plus m is equal to 0, and x squared plus mx plus r is equal to 0 have real and equal roots. They have real, but also equal. So what is in capital letters? Can we solve for the value of r and m if r is greater than 0 and the m is also greater than 0? Okay, so from the nature of roots, we know that for roots to be equal, the b squared minus 4ac must be equal to 0. Okay, for the real part, I'm not going to go into details because it's kind of obvious. The discriminant must be greater than 0. So from the first equation, that's what I'm going to focus on. My a is a 1. Our b will be r, which is the coefficient of x, and then this is going to be m. So I'm going to substitute that into this. Okay. So we're going to say b squared, which is r squared, minus 4, the a is 1, and then the c is m, is equal to 0. And then I can make, I don't know, I can isolate. Will it make sense though? Okay, I'll have r squared is equal to 4m, positive 4m. Okay, what is so special about this? Should we make m the subject or r the subject? I don't want square roots. Let me just make m the subject, which is r squared over 4. Then I'll go to the second equation and do the same thing. So from the second equation, x squared plus mx plus r. So our a is a 1, our b will be m, and then the c will be r. So when you apply the same thing, because equal roots must be equal to 0, that's going to be m squared minus 4 times 1 times r must be equal to 0, which means my m squared is going to be equal to 4r. Okay. And then I can make m the subject, but it's no good use. I can just get this and then replace it somewhere there. Where there is m, I'll put r squared over 4, so that it is r squared over 4 is equal to 4r. Now we're squaring this. Okay. And then when we square that, it's going to be r to the 4. But why can't I move this to the left? just to make life easy for me. So that I have r squared over 4 squared minus 4r is equal to 0. You can open that up. Have r to the 4 over 16 minus 4r is equal to 0. Get rid of the 16, multiply through by 16. Okay. Oops, sorry. So that's going to be r to the 4 minus, we know that same times 16 times 16 times 16. So this cancels that. 16 times 4 is going to give us 64r is equal to 0. R is common. You take it out. I'll have r cubed minus 64 is equal to 0. So either r is a 0 or you can find r cubed is equal to 64, and then we can find the cube root of 64. So cube root of 64, I'm getting just a 4. So either r is a 0 or r is a 4. Then I can just use this and substitute into that equation of m, where we said m is going to be r squared over 4. So if we use a 0, it's going to be 0 squared over 4, which is a 0. And then if we use the 4, it's going to be 4 squared over 4. That is 16 over 4. And then the answer becomes a 4. I don't know, but that would be my approach. That would be my approach. But remember, the question told us that r is greater than 4. Sorry, r is greater than 0. And then m is also greater than 0, which means, in essence, these zeros are not going to count in our solutions. They have no use since r is greater than 0 and even the m is greater than 0. So shall go with 4 and then 4. All right, then we move on. Question number next. Question 2. Okay, so they're telling us that we're given a quadratic sequence, 20, 12, 10, 14. They want us to determine the nth term. So we need to find the first difference and then the second difference as well. So if that is a 20, come on, what's happening? Hello. The pen is leaving me there. Okay. What did I do wrong, guys? $10, $20. Okay. I think it's behaving now. Okay. So that is a 20. We have 12, we have 10, we have 14. So when you subtract this, remember it's T2 minus T1, not the other way around. So 12 minus 20 is going to give me negative 8. 10 minus 12 is a negative 2. What's happening? Did I copy the correct thing? Yes, I did. This is 20, 12, 10, 14. And then 14 minus that, which is a 2. That's correct. Then when we subtract this, negative 2 minus 8, that's going to give us a 6. Okay. But something's not right. What's wrong with my subtraction? This is a 4. Then 4 minus 2. We get a 6. Yeah, makes sense now. Okay, so then we know that our 2a is going to be equal to the 6. Divide both sides by 2, which means a is a 3. Then we have 3a plus b. It must be equated to that first difference, negative 8. But since our a is a 3, So 3 by 3, that's going to be 9, plus b is negative 8. Move the 9 that side, which means b is negative 17. Then we know that a plus b plus c must be equated to the first term, which is 20. So 3 minus 17 plus c is a 20. That's a negative 14. When you put it that side, it's going to be a positive, so which is a 34. Which means the equation is going to be now 3n squared minus 17n plus a 34. Okay. Then the first difference forms an arithmetic. That's correct. Determine between which two successive terms in the quadratic sequence the first difference will be 148. Okay, so we need to start by determining the nth term of the first difference. Okay, and then if the Tn is 148, what position will it be? So from the arithmetic, we have a plus n minus 1 into d. Our a is going to be negative 8 plus n minus 1. The common difference is a 6 for this case. Now, if I replace the Tn with 148, and then I solve for n, so I can move this 8 that side, I'll end up with 156 is equal to n minus 1 into 6. If I divide both sides by 6, is it going to make sense? Yes. So over 6 and over 6, I'm getting a 26 is equal to n minus 1. I'll move the 1 that side, which means n is a 27. So, in other words, position number 27 of the first difference, that's where we're going to have our difference of 148. Okay, so what this translates into is that in relation to the general format of the pattern or the sequence, we're going to be looking at terms T27 and then T28. That's how it works. An example, we can see that this first term number 1 of the first difference is between T1 of the quadratic and T2 of the quadratic. Term number 2 is between T2 and T3, which means term number 27 must be between T27 and T28. All right, then determine the smallest value of n for which the Sn is greater than 10140 within the arithmetic sequence. Okay, so they specified arithmetic. So with arithmetic, which is the first difference, we said our a is negative 8, n is what we need, the Sn is greater than 10140, the d is a 6. Get that, and then substitute it into the Sn. It will be n over 2 into 2a plus n minus 1 into d. This formula can be obtained from the formula page. Okay. Now, I'm gonna replace this. Okay, I'm gonna put it on my right hand side and put the inequalities. Okay, so that's gonna be n over 2 into 2 times, we said our a was what? Negative 8. Okay, that's negative 8 plus the n minus 1 into a positive 6 must be greater or equal to, we said 10140. Okay, greater or equal to 1. 1, 0, 1, 1, 0, 1, said what? 240, 1, 0, 1, 4, 0. Okay, then we open up the brackets. It's your choice. You can start by getting rid of these two or opening it straight. I don't know. It's just your choice. That's negative 16. You can open this up. Plus 6n minus 6 is greater or equal to 10140. Then when I open this through, I'm gonna have negative 8n plus 3n squared minus 3n is greater or equal to 10140. Then I can form a standard solution. That's gonna be 3n squared. I link this up. I get negative 11n. I move this aside. Minus 10140 is greater or equal to 0. Then I can use my quadratic formula if I want. So negative b plus minus square root of b squared minus 4ac over 2a. So negative 11 plus minus square root of negative 11 squared minus 4 times 3 times negative 10140. Okay, I'll divide this by 2 times 3. So if I punch this into the calculator, this is what I'm getting. Okay, minus, okay, that's gonna be plus 40 over that. So my first n is gonna be a 60 if I use a plus. And then if I switch the middle sign to a negative, okay, I'm getting negative 56,3333 and so on. But remember, our positions can never be negative. In other words, we're only focusing on whole numbers, and plus positions can never be in decimals. Now, since they told us that the sum is greater than 10140, but this n is just going to give us the exact value of 10140. So I can draw the conclusion and say therefore n must be equal to 61 because our n is greater than 60. Okay, so n is 61. Yeah, makes sense. Okay. Then 2.2 is a sigma. Okay, you're telling us that if r is 1 up to r is 5, those are the limits of r plus b must give us 10a. They want us to determine b in terms of a. All right, let's try to substitute. So if r is 1, that's for the first time, I'm going to have 1 plus a. Okay, remember sigma represents summation or addition. Okay, so I'm adding. If r is 2, that's going to be 2 plus b. If r is 3, that's going to be 3 plus b. If r is 4, that's going to be 4 plus. Okay, I'm saying that's going to be 4 plus b. And then if r is 5, that's going to be 5 plus b. All this must be equated to 10a. So if we collect the like terms, I'm having 1 plus 2 is 3. That's a 6. That's a 10. That's a 15. Okay, that's 15 plus 1, 2, 3, 4, 5. Must give me 10a. They want us to make b the subject to solve for b. So I'm going to move the 15 that side, or I can divide through by 5 so that I have a b is equal to 2a, and then make b the subject. That's going to be 2a minus 3. I don't know. I feel like that is it. Okay, so that is 2.2. Then question number 3. Question number 3. You have the following geometric. Okay. You have 24 over x, then 12, then 6x, and then 3x squared, and the story continues. They want us to calculate the sum to infinity. So from the formula of sum to infinity, which is a over 1 minus r, what we need is a common ratio. I can use T2 and T3 for me to get that common, or I can even use T21, no problem. So if I get my T3 divided by my T2, that's going to be 6x over 12, which is a half x, or x over 2. That is my r. And then I just need to replace or substitute. So that is my first term is 24 over x. I'm dividing it by 1 minus x over 2. Okay. Then what do we do next? What do we do next? We simplify. No? Yeah. So let's apply our normal fraction kind of things. We're dividing by, okay, so when I simplify this denominator, it's going to be 2 minus x. Let me just say that, over 2. Okay. Then let me just put it slightly down here. It's a lot of space. Then I'm going to have 24 over x times the 2 is going to go on top. This is 2 minus x. Okay. Then I'll multiply the top part, that is 48. This and this is 2x minus x squared. So that becomes the sum to infinity. What did we do down here? So remember, these are fractions with different denominators. So look for the LCD, which is a 2. Then 2 divided by 1 is a 2. 2 times 1 is a 2. 2 divided by 2 is a 1. 1 times that is that. Then you end up with that. Remember, you need to change the sign to multiplication. And then this goes on top. That comes down. That's how you end up with that. Then 3.2, determine the values of x for which the sequence converges. Now, the condition for convergence is that -1 must be less than r, must be less than +1. These are the limits for any sequence to converge. But we found our r to be x over 2. Okay, so where there is r, we're just going to put x over 2. So that's going to be -1 is less than x over 2 is less than 1. Then we multiply through by 2. Just to get rid of this the part. So it means going to be -2 is less x, and then less +2. So those are the limits or the values of x for which condition must converge. And then they're asking us for which values of x would the series increase. Now, since we know that converge is just to get narrower and narrower, smaller and smaller, up to infinity. And they're telling us r has to be less than 1. So for the series to increase, r has to be greater than 1. Okay, but our r is x over 2. We can say it's greater than 1. Then solve for x, which means x must be greater than 2. And then lastly, 3.4, they're telling us that if x is a 4, can we determine the sum of the sequence to 15 terms? So we know that this sequence is geometric. That is true. That is very, very, very true. And we know that the sum of a geometric is given as A into, I'm going to say R of n, R to the n minus 1. Because if x is 4, if the x is 4, which means the R is going to be x over 2, which is 4 over 2, which is a 2. That's why I'm using this. Then over R minus 1. Okay, so our first term was 24 over x. Now that is 24 over 4, which is a 6. So 6 into our R, we said we translate it into 2 to the 15 minus 1 over 2 minus 1. So when I punch that into my calculator, it's 6 into 2 to the 15. We're subtracting the 1 over 2 minus 1. Okay, I'm getting 196602. That's what I'm ending up with. I don't know if that's what people are getting there as well. Okay, so that's how I would have gone about that. Start by replacing the x to r to get a 2, and then find the value of a, which is the first term, and then substitute into the formula. So that is question number 3. Then question number 4, which is functions. Come on, what's happening? Okay, thank you. The graphs f of x is x plus b squared plus q. This is a parabola. F. G is a over x plus b plus c. This is a hyperbola. Okay. Parabola, because we're having a square somewhere. Hyperbola, because the denominator is having x. They have the following properties. They're telling us a, which is 5 over 2 to 0, is a point on f. Where is a? Okay, where is it? P is the turning point. Okay, thank you. Vertical asymptote passes through 1. Okay, horizontal passes through 2. Thank you. G passes through the origin. All right. Then they're asking us to show that the equation of G can be written in this format. So remember, G, we said, is the hyperbola. So what usually happens is we're saying it is C A over x plus b plus c. Okay, so what normally happens that B represents the vertical asymptote, and then C represents the horizontal asymptote. So I'll start by substituting those. So A over, since this vertical is a 1, I'm going to switch the sign there and make it -1. The horizontal is a 2, it maintains its sign. Then we need to get one more point that is not part of this. And that point can only be found by O, which is the origin. So we need a point that G is passing through. The only point is the origin. We know that with the origin, X is a 0, and then Y is also a 0. So we just replace, substitute into this formula, and solve for A. So 0 is equal to A over -1 plus 2. Move the 2 that side, you're going to have a -2 is equal to A over -1. Multiply both sides by -1, which means A is a 2. What was the question asking for? Show that the equation of G can be written as this. Now, I know there are learners that will just put the equation just like that. This question is, in other words, telling you to prove that the equation of G is this. So when you substitute those values of yours, we're saying G of X or Y is equal to A, which is a 2, over X minus 1 plus a 2. Please and please remember, g of x, f of x, they all represent just a single value y, single letter y. And then they want us to get the coordinates of P. So what we know about P, is there anything we know about P? No. We know nothing about P. Only thing we know is that P is a turning point where x is what? Where x is a 1. Why we don't know? But when you look at the format that was given of the parabola, remember we have 3 formats. This format is the turning point format, where P represents the x value of the turning point and Q represents the y value of the turning point. So I'm just gonna try to do the substitution, and f of x, we said it's a y, is equal to x. P is the x coordinate of the turning point. And this we say it's a 1. Okay, we can see it's a 1. So we're gonna switch that sign from a positive to a negative. Okay, we're saying x minus 1. We square that. Plus the q that I don't know. Okay. Then I'm gonna need another point that this graph is cutting. The graph of f. And that point is A. So at A, we're saying that x is 5 over 2. And then y is a 0. So I'll say 0 is equal to 5 over 2 minus 1. I square that plus a q. Okay. Then I just use my calculator, saying 5 over 2 minus 1 squared. I'm getting 2,25. You can always give it as a fraction, no problem. So 9 over 4 plus q is a 0, which means q is negative 9 over 4. Okay, so what was the question asking for? The coordinates of P. So we're saying P is going to be 1 and negative 9 over 4. So we need to just go through all of this. We need to show all the workings and obtain the marks. Then 4.3, they want us to determine the vertical asymptote of P. If P of x is the same as G of x minus 1. So they're getting the graph of G, okay, and then they are shifting it 1 unit to the right because it's a minus 1. So when there's a minus, you're shifting to the right when it is next to the x. If it's a plus, you're shifting to the left. So in this case, what I'm going to do is since our graph or our asymptote is here and they're telling us it's shifted 1 unit to the right, so which means this is going to be at 2. So which means we're just going to say x is equal to 2. That's why it's a 1 mark. Then determine the equation of the axis of symmetry in the form of this. If m is less than 0. Remember, for axis of symmetry of a hyperbola, it's always given as y is equal to x plus c if the m is positive, or negative x plus c if the m is less than 0, or if the gradient is negative. Okay, so now we have the general format. What we need is just the values of x and y that we're going to substitute. Now the values that we substitute will be the asymptote values, which is 1 and 2. Okay, so where the asymptotes intersect. So we said at 1 and 2. So where there is y, I'm gonna put I'm going to replace or substitute with a 2. Okay. And then where there is x, I'll replace it with a negative 1. Then I solve for c. So I put that negative on that side. So c becomes a 3. So my equation is going to be negative x plus a 3. Then 4.5, they want the equation of k if k is the reflection of g above the x-axis. Remember, it's a hyperbola where we said it's x minus 1 plus a 2. So when you reflect above the x-axis, let's go back to the graph. So if we have this point here, okay, I'll call it negative 2, okay, this point, negative 2 and 2. When you reflect it about the x-axis, this point must move in this direction, downwards, but it will be just the mirror image of each other. So the x is maintained, but then the sign on the y is the one that changes, okay? But since we see the whole of this represents the y, I can just introduce a negative sign in front of that thing, and then I'll be good to go. Okay. So what happens, or what I was doing, is introduce a negative sign there. Now introduce the negative, it's going to be negative 2 over x minus 1. Then this negative affects that positive, and then it ends up being a negative 2. So that becomes the equation of k. So k of x is equal to that. All right, so this is the equation that they want. The bottom sign will not be affected since it can only affect it once. Then for which values is f prime of x times g prime of x greater or equal to 0? What does this mean? So we know that f prime will represent the gradient that we know. And then they're talking about the g of x to be greater than 0. So we're looking at a scenario where this is positive. In other words, it's above the x-axis. And then the gradient of f is also positive. Does that make sense? No. Does it? Yes. Where is f? F is the parabola. Gradient is positive just from this point, moving in that direction. It's increasing. And then the g, we said it's just above 0. The g is above 0 between positive 1 and the positive infinity. But g can also be above 0 between now the g is equal to 0 at this point, and it's below 0 within this point. Okay, so scenario number 1, either I focus on this upper part where the g is on top, and then the x, this f is also above. Okay, but we know that g cannot be equal to the 1. So what I'm going to say is that x should be greater than 1. That is condition number 1. Then the other condition is if the gradient is negative of f, and then this graph is below. So we're looking at the positive and the positive to be greater than 0, or negative and negative to be greater than 0. So both graphs to be below. Okay, so where do I find both graphs to be below? So between 0 and 1. Actually, I'm seeing both graphs to be below. This one is below, then this one is decreasing. So we're going to say 0 less x less 1. That's also another condition. So 0 less x less 1. So these are the two options we had. Then for each values of x, sorry, k, or the equation g of x, which is x plus k, have two real roots, but of opposite signs. Okay. So which one is g? G is this 2 over x minus 1 plus 2. So what do they mean by two real roots? So roots are basically the x-intercepts. Okay. So we shall say that k must be greater than 0. Then the graph will have those two roots. Okay, so k has to be greater than 0. That is question number 4. Question number 5, they're telling us the graph of h is given as that, where a is greater than 0. They sketch it for us. Okay, then they want the coordinates of q. Is q the y-intercept? Looks like. Okay, so if it's a to the x, we know that at q, x is a 0. Okay, which means a to the 0, which is a 1. So the coordinates will be 0 and 1. Then for us to get the value of a, we just need one point, which is p. So we're going to say y is equal to a to the x. Our y is a half, that is a to the negative 1. Okay, you can change that, or you can multiply by the reciprocal. Okay, so that is a half is equal to the same as 1 over a. Do your cross multiplication, which means a is a 2. Okay, so you're getting a as a 2. Then they want us to write the inverse. So if a is 2, which means y is 2 to the x. 2 to the x. So how do we write the inverse? Okay, so remember, for as long as it is exponential, then the inverse is just going to be a log graph. So that is log, the base is at 2. Then we just put the x there. And then we're done. All right, then sketch the h inverse in your answer book, clearly show the intercepts. So if I sketch it just here, they don't necessarily have to be together, but let me just put it in. So remember what we said, if this is 0 and 1, we switch the points, call this the 1 and 0. Okay, if this is negative 1 and a half, then we're going to look at a half and negative 1, probably somewhere there. So this graph is going to move just in that sort of direction. It will move towards the y-axis. So this is going to be the inverse. So say h negative 1. Or you can call it the log something something. Okay, so that is that for the sketching part. Then they want us to write the domain of the inverse. So domain of the inverse is the same as the range of the original. Okay, let's see if that's going to make sense. The range here would have been y to be above 0, since the x-axis is the asymptote. So y must be greater than 0. So when they talk about the domain, you can see that this graph does not cut this y-axis where x is a 0, but rather It just tends towards it and then moves to the right. So we can say that x, since domain represents x values, x is greater than 0. Okay, then we move on. They're telling us hence or otherwise. Okay, hence or otherwise, can we determine the values of x for which the log x base 2 is greater than 1. The values of x for which the log x base 2 is greater than 1. In other words, it's above 1 on the y. Good people, what do you think? What do you think? The log x base 2 is greater than 1. So from our graph, remember we said this was a half, and then this was -1. They want it above 1. We can go back to the original, which is 2 to the x as our y. If we replace x with a 1, okay, 2 to the 1, our y is just gonna be a 2. So which means the coordinate of the original would be 1 and a 2. Okay, let me just put it there. So if x is a 1, the y here is gonna be a 2. So that's 1 and a 2. So if I'm to draw my point, this one on the inverse, it's going to be somewhere here, which is a 2 and a 1. Now the question is asking us for which values of x. Okay, for which values of x is this greater than a 1? So we can see that at this point, that's where the 1 is. For it to be greater than 1, this is the section of interest. And in that case, the x has to be increasing. So I'm going to say x has to be greater than a 2. Okay, I'm saying x has to be greater than a 2. That's my opinion. Okay, then 5.7. Okay, so with 5.7, if g of x is given as 100 times 3 to the x, they want us to calculate the value of x for which h and g are the same. Where is h? We said h is 2 to the x. No? Yep, 2 to the x. Let's see. So for x to be the same as g of x, so 2 to the x is the same as 100 times 3 to the x. Okay. Then, yeah, perfect. Then we need to apply the right mechanisms. And this question might require the logs. Fine, I'll divide both sides by 3 to the x, 3 to the x. So this and this cancels. Then I'm going to have 2 over 3 to the x is equal to 100. And then you have to introduce logs. This is not usually taught since we no longer teach the laws of logs in details. Okay, we just focus on the power rule. But if we introduce logs, you can say log on both sides. So this x will come that side since we have now 2 powers. So x log 2 over 3 is equal to the log of 100. So the log that we are introducing is more like a base 10 log. So that's 2 over 3. Then divide both sides by log 2 over 3. by log 2 over 3 by the log 2 over 3. Okay, so in this case, we have, we can say log of 100, okay, over the log, I said log, guys, okay, 2 over 3. And that gives us negative 11,358. Something like that. Something like that. That's what I get. Okay, then that's what would have happened anyway if this question was to be asked. Then the next question, which is question number 6. Question number 6. They're telling us that the graph f of x is negative 27 negative root 27x, where x is greater than 0. P is that point, lies on the graph of f. Okay, so we have restricted functions. Then use the graph to determine the values of x. Use the function to determine the values of x, where f of x is greater or equal to negative 9. So when you look at this point, that's where we find our negative 9 for the y. And then the value for negative 9, or for f of x to be greater than negative 9, we're talking of this region where it is above negative 9. Okay, it's between 0 and this 3. Those are the values of x that we're focusing on. So we're going to say 0 is less or equal to x, less or equal to 3, since they said equal or greater. Okay, then 6.2. 6.2. Write down the equation of the inverse in the form of y, and we need to indicate all the restrictions. So if our original is negative, we said square root of 27x. Let's just confirm it. Don't want us to do our own things. Okay, and it gave us the restriction of x being greater or equal to 0. When we are finding the inverse, remember the rules still stay the same. We switch these variables. So we're going to have x is equal to negative square root of 27 with y. So we're also going to keep the condition, and we say y must be greater or equal to 0. Then for us to get rid of everything and make y the subject, we need to square both sides. So if I square this, then I square that, I'm going to have x squared is equal to just the 27y. Then I'll divide both sides by 27. So y becomes x squared over 27. And then what's going to happen here is that x must be less or equal to 0, since we're no longer dealing with the roots. So x must switch the condition. Okay, so that is 6.2. Then they want us to sketch the inverse in the answer. Indicate all the intercepts with the axis and one other point on your sketch. Okay, so what I can see is that since this is 3 and negative 9, we can play around with it and switch it around. So that's going to be negative 9 and 3. So negative 9 could be somewhere there. Oh, anyway. And probably 3 could be somewhere there. Then we have the 0 point, that is fine. So we can already see with these 2 points where the graph is heading to. So we can have something like that. So since they asked for an extra point, just use that one. Yeah, call it -9 and then 3. That's the quick one to use. Or if you have time, yes, you can replace it with the 1 and what and so what you end up with. But remember, we're saying x must be less or equal to 0. So if you put a -1 there, you're going to have a decimal somewhere there. So any other point just on the left would make sense. Then now, done. We need to describe the transformation from F to G. Okay, remember, F was -√27x, and now G is square root of 27x. Still, the condition is the same. So the only difference is the negative sign. And we said if there is a negative sign or there is positive, it's just a reflection above the x-axis. A reflection using the x-axis as a mirror line. So we're going to say that is a reflection in the x-axis or the horizontal axis. All right, so that is question number 6. Then 7, this is a finance question. They're asking us at what annual percentage interest rate compounded quarterly should a lump sum be invested in order for it to double in 6 years. So the question wants us to get the I. Do we know the P? No, we can call it X. Do we know the A? We can just call it 2X. Then what's the N? It's a 6. But we're compounding it quarterly. So it means it's going to be 6 times 4, which is a 24. Okay, so from our compound interest, we have P into 1 plus I to the exponent of N. So it's saying 2x is equal to x into 1 plus I over 4 to the exponent of 24. This cancels that. So then I'm having 2 is equal 1 plus I over 4 to the exponent of 24. Then I can find the 24th root on both sides. Or what people normally do is they get the reciprocal of 24, which is 1 over 24. Like 1 over 24, and then to the exponent of 1 over 24. No problem. If I find the 24th root, you can just use the cube root and then you remove the 3 and then replace it to the 24. We enter our 2. We're getting 1,02930. I'll just give quite a number of decimals before my final answer. Then I'll move the one that side. I'll have 0,02930 is equal to I over 4. Then I'll multiply both sides by 4 and then multiply by 100. Okay, so I'm getting my I as 11,2%. So that is 7.1. Okay. And remember, this person is investing just a lump sum. So we cannot confuse it with the annuities. 7.2, they're telling us that Simon buys furniture to the value of 10,000, but he decides to borrow the money on 1st of February 2020 from a financial institution that charges this much compounded monthly. This guy agrees to pay $450 per month. Okay, the agreement of the loan allows him to pay equal monthly installments from the 1st of August. When did he borrow the money? 1st of February. Oops, okay. So calculate the amount owing to the financial institution as of the 1st of July. So between 1st July and then 1st February, how many months are there? Those are basically, this like 7 minus 2, which is like 5 months that we're talking about. So which means this money is going to grow for 5 months using compound interest. So A is equal to P into 1 plus I to the exponent of N. Our P is the 10,000 into 1 plus, remember the I we said is 9.5%, compounding it monthly to the exponent of 5, since it's already in months. Then we punch that into our calculators, that's 1 plus, so it's 9.5% over 12 to the exponent of 5. Okay, I'm getting 10402,15 friends. Okay, so that is what this guy must pay back. Okay, then how many months will it take Simon to repay the loan? So they want us to get the N. Okay, but since this is a loan and this guy is going to be paying monthly installments, then it forms what we call an annuity. Okay, but which type of annuity is it? It's the present annuity, the P value. Okay, the P. So we use the P formula where we say that the PV must be equal to X into, that is 1 minus 1 plus I to the exponent of negative N. We're dividing it by I. So the value, the answer we just got now will become our P. So we're saying our P is 10402,15. Interest rate is 9.5 compounded monthly. And then the X is going to be the 450 that we know. Okay, so I'm just going to say 10402,15 is equal to 450 into 1 minus 1 plus, say, 9.5% over 12 to the negative N over 9.5% over 12. Okay, so we can start by simplifying these two before we take them that side. Or you can take this aside and then you divide, whichever one is simpler. So I'll say 450, I'm dividing it by 9.5% over 12. Okay, getting a big answer. So 10402,15 is equal to 56842,105 into 1 minus. If I simplify this bracket, percent 1 plus 9.5% over 12 0.007917 to the negative N. Then divide both sides by 56842,105. So 1040 said 56842,105. So those two will cancel. Then 56842.105. Okay, that's giving us a small answer. The small answer is 0.183 is equal to 1 minus, said 1,00 1 so 7 yellow 7917 to the negative N. Okay, then I'll move the one that side. 0.183 subtract 1. That will give me negative 0.817. I'm getting a negative 1,007917 to the negative N. So this negative and negative will give us a positive. Okay. But remember, with this N of ours, there's something we didn't do. And I think we need to do it just to be on a safe side. We did not include the 12. I don't know, we can, it's fine, let's include it. so that we are safe at the end. Okay. So that's a 12, and that's also 12. Okay. Then from there, you have to introduce your logs on either sides. It's going to be this the base. So I'll have negative 12n is equal to the log. That's the base, which is 1,007,917. And that's 0,817. And I punch that into my calculator. 0.07917. And that is 0,817. That's giving me negative 25.63. Then I'll have to divide both sides by negative 12. Okay, I divide that by negative 12, end up with 2,135 something. It's 2, but why did I multiply by 12 if I may ask myself? What is the question asking for? How many months? Yeah, we're on the right track now. We have to multiply. Okay, we can just see this representing the number of months. Okay, so this is 25. It's going to be positive. Okay. Because the number of years is just going to be 2,1359 years. Again, multiplying it by 12 again. Back and forth. Okay, nevertheless, if we round this off, it's just 26 months. Because 25,3. Remember, the 12n is representing how many months in total. All right, then, oops, that is that. That's what you had to do. Then what is the balance of the loan immediately after the 25th payment? So we need to find the outstanding balance. So since this is a present value, and we say that with the present value, we have 450 as the payment into 1 minus 1 plus, we said 9.5% over 12. I will say 9.5 over 12. Now the period that we're talking about is the period that is left. Now, since we agreed that we're going to take 26 months, yeah? Since we got 25, something, and we rounded it off, because we need another month for it to work out. Now, since this guy has now made 25 payments, how many months are going to be left? We can go back to the original answer, and then we subtract the 25 or 26. We subtract the 25, no, it's not making sense. Can't say that. That is wrong. If we get, let's say, 25,63, and then we subtract the 25 months, we left with 0,63. In other words, it's just a fraction of a month. Okay. So if we punch this into our calculator, guys, it's going to depend on your rounding also. Okay. If you use a lot of decimals, your answer might be slightly lower than ours. If you use few decimals, your answer could be slightly higher, but just it's within the same range of decimals. Okay, then we have 9.5% over 12. So I'm getting 281.68. 281.68. So this is how much it's going to be left. You round it off, roughly 282 rands. Okay, so that is question 7. Question number 8, which is calculus. Okay, determine the f prime of x. If f of x is 3x squared plus a 2x. Okay, so from what is it? From the formula page. There is that limit as h tends to 0, f of x plus h minus f of x over h. This is the formula we use for first principles. Then, since we were given the f of x as the 3x squared plus 2x, we need to find the f of x plus h. In other words, where there is x, we're just going to replace it with x plus h. Okay, so that's going to be 3 into x plus h, we square that, plus 3 into x plus h, minus brackets 3x squared plus 2x over h. We're saying the limit as h tends to 0. Okay. Then we're going to open up using the FOIL. So limit as h tends to 0, we have 3 into x squared plus 2xh plus h squared plus, that's going to be 3x plus 3h. I can open this up, which is 3x squared minus 2x. Everything is over h. Then the limit as h tends to 0, simplify that. I have 3x squared plus 6xh plus 3h squared plus 3x plus 3h minus 3x squared minus 2x. Now, whenever we deal with first principles, certain things have to cancel. So this is canceling with that. Okay. What else is canceling? Nothing. So we just need to work around this and work around that. Okay, yeah. So what we see is the limit as h tends to 0, just left with this. Something doesn't add up, guys. What did I do wrong? Why did I put a 3 up there? Yo, modem. It looks like I'm tired. This is a 2, not a 3. So this is a 2x and a 2h. I'm wondering why the 2 is not cancelling out. Okay, so this is a 2x. So this cancels that. Yeah, then factorize out the h. So you have 6x plus 3h plus a 3. Everything is over h. And that one is over h. Then cancel the h. This h cancels that. And then the limit as h tends to 0, that thing's gonna fall off. Okay. Then we have 6x plus a 3. So that is going to be the first principles. Okay. Then 8.2. 8.2. They want us to find dy dx. Interesting. So whenever we have root signs, change them into exponents. Okay, so that's going to be y is equal to 4x to the exponent over half minus 8 over x to the exponent over half plus pi x cubed. Then 4x to the exponent over half minus 8. Let's take the x to be numerator. It's going to be negative a half plus pi x cubed. So since we are deriving with respect to x, we can now say our dy dx is going to be a half times 4, which is 2x to the negative a half. And this a half negative times negative 8, that's going to give me a positive 4x. When I subtract a half, just get a negative 1. Then from there, the 3 comes that side, it's going to be 3 pi x squared. I could leave it like that. 2x to negative 2 plus Oops, what's wrong with me? We say it's not -1. So it's subtract 1 there. That's -1/2 minus 1, which is -3/2. Instead. Okay, guys, 8.3. So that is 8.2. Then 8.3, the graph of g of x is x squared plus b over x equal 96. It has a minimum at this point, right, with the values of n, b. So when we talk of minimum, maximum, talking about the first derivatives. Okay. So what we're going to do, we're going to differentiate this. Okay. And after differentiating it, we equate it to 0 when x is a 4. Because when they talk of a minimum, this is like a turning point, and we know that the gradient at the turning point is always 0. Okay, gradient is always 0 at the turning point. And the first derivative represents the equation of the gradient of the graph at any point. Okay. So what we do, we have ax squared. Let's see if it's gonna make sense. If it doesn't, we leave it now. 8.3. Okay, so we have ax plus b over x. Okay, is equal to 96. X is a 4. So we said, let's get the first derivative. So that's gonna be ax squared plus bx -1 is equal to 96. Okay. Then divide x. Okay. Divide x, it's gonna give me 2ax minus b x -2. This is gonna die out. Is equal to 0. Okay, so we have 16a plus 32. That's gonna give us 48a is equal to 96. Then 96 divided by, oh, that's a 2. I'm not mistaken. Yeah. So that's a 2. Then I'll get this 2, replace it there. So which means 128 times 2, we get the 256. Okay, so that is how that question would have been done. Okay, then question number 9. Okay. You're telling us that the graph of h, which is -x cubed plus x squared plus bx plus c sketched below, give us the values of a and b to be 6 and 0, which are the turning points. Then t is 3 and y is a point on h. Then the graph of h passes through the origin. Okay. So having read that, they're telling us to show that a will be a 12 and b will be a -36. Okay, so we have number 1, b is a turning point, and also a is a turning point. Okay, then we know that since the graph is passing through the origin, the c is going to fall out since c is going to be 0. So we only going to be having -x cubed plus ax squared plus bx. Okay. If I use this point first, and then I substitute. So 0 is equal to, what is 6 cubed? Which is 216. plus 6 squared. It's going to be a 36a plus 6b. And I just make this an equation. I'll have 36a plus 6b must give me 216 positive. I can divide through by 6. 6a plus a b must give us, I think, a 36, which is true. Then make b the subject, which is 36 minus 60. Cover the first equation. And then marks are they? So if that is the first, there are 3 marks. Oh, why are we doing? Okay, it's fine. Let's see if we can get them. Then let's find the first derivative. First derivative, which is dy dx. That's going to be negative 3x squared plus 2ax plus a b must give us a 0. Okay. Having done that, I feel like this is a long route. Yeah, it's a long route, but it's fine. Let's see. When I replace x with a 6, that's going to be negative 3 times 36, which is 108. It's negative 108 plus 2 times 6, which is 12a, plus a b must give us a 0. But we said our b is this. So negative 108 plus 12a plus 36 minus 6a must give us a 0. So this and this is going to give us a 6a. Negative 108 plus 36, getting a 72. Then I'll divide both sides by, wait a minute. This is positive 6. That's a negative. Okay. So 72 divided by 6, we're getting 12 for A. Then I can replace this 12 here. And then my B is going to be negative 36. Okay, so that is one way of getting that, in as much as the marks look too small for all that I've done. Alternative number 2 could be using the factor method. Since we have this as a turning point and an intercept as well, which means I'm going to have x minus 6 squared. And then this point also is an intercept with the root, which means I can also have x minus 0. Must give me a 0. If I try to open this, I'll have x squared minus 36. Oh, 36, man. It's 12x plus a 36. And then I'm multiplying by x, which is x cubed. Something's off here. Because with this opening, it's going to be negative. It's fine. Let me keep an a there, just in case. Okay, x cubed minus 12x squared plus 36x. That is my y. Then if I try to substitute 6 and 0, Is it gonna make sense? Because now this is meant, with this opening, the A is meant to be a negative. That's what I'm saying. With the way it's already here. What's wrong with me? So that's a negative. Okay, so if that's a negative, then it's negative x cubed plus 12x squared minus 36. I think we can use that and then get those answers directly. Whichever way, all we need are the answers. Then they want the coordinates of A. We found the first derivative, didn't we? It's fine. Let me just find it again. So coordinates of A, we need the first derivative, which is going to be dx, which is negative 3x squared plus a 24x minus a 36 is equal to 0. And then we solve using either the quadratic or the vector method. You can even start by dividing 2 by 3 if you want. So if I use my quadratic, that is negative 3, we have x squared plus 24 minus 36. Getting x as a 2 or x as a 6. So since we're focusing on A is going to be a 2. And get this 2, we replace it into the original. So when that happens, our y that we end up with is going to be negative 2 cubed. That's correct. Plus 12 times 2 squared minus 36 times 2. I'm getting negative 32. Okay, so negative 32 becomes the answer. Then they want us to get the value of y around about here. So if x is 3, what is y? So just replace that. Negative, we have 3 squared, no, 3 cubed, plus 12 times 3 squared, minus 36 times 3. Okay, so that is giving me negative 27. And they're asking us, is this graph concave up or down at point T? Okay. What do you think, guys? So we need to find the second derivative. And then at the second derivative, where there's x, we're going to replace it with a 3. So this is going to be, let me just say f double prime x. That's going to be negative 6x plus a 24. When I replace x with a 3, it's going to be 6 times 3 negative plus a 24, which is a 6, because that's negative 18 plus 24, which is a 6. We can see that 6 is greater than 0. Okay, so which means the graph is concave up. So we can say graph is concave up since the second derivative of x, let's put 3, is 6, which is greater than 0. Okay, just at point B. Then determine the coordinates of the point of inflection. So the point of inflection is okay, so we're saying for the point of inflection, we need to find the second derivative. We need to find the second derivative and equate it to 0, which we got. Okay, so we said negative 6x plus 24 must be equal to 0. Move the 24 that side, negative 6x is equal to negative 24, which means x is a 4. Then we need to get this 4 and then substitute it into the original. So we're going to have negative 4 cubed plus 12 times 4 squared minus 36 times 4. And then that is going to give us negative 16. So which means the point of inflection is 4 and negative 16. Number 10, which is also calculus. They're telling us that a hotel has 72 rooms that it can let to clients. The daily rent per room is 500. Then if the rent is now increased by 100 rand per day, 2 rooms are going to be left vacant. And then the rent is around X per room per day. X must be greater than 500. Can we show that the total daily income is given by that? So what we need to know is we need to set up equations or expressions just for what might be happening here. As an example, if you look at the rooms and the income that is coming through. An example, if I talk about rent being 500, and then there was another scenario where they said if the rent is increased, so if we increase it, it's going to be 600. So what's going to happen? How many rooms are there that are rented? We're saying there are 72 rooms. Okay, and then if the rent was increased to 600, then it will only be 70 rooms available. Not so. Yeah. Then what would be the income? What total will be collected? So if it's 600, that's going to be, does it make sense though? Because it is 600 by 500. The rent is 500. Now the rent is 6. With this much. Let's see what we have. So what we're saying is that originally, if we have 500 and all rooms are rented out, it would give us the 36,000. And then if it is 600 and only 2 rooms are left empty, we could have the 42,000. Okay, so how do we now work this out? Where X is greater than 500. So we need to look for the total increase or the rate at which the increase is taking place. So we can say if we have X minus 500 over 100. Okay. X minus 500 over 500. And then this is going to be multiplied by okay, so I'm going to say 72 minus the rate that is causing everything to decrease, because now if 2 rooms are left vacant, then the rate kind of decreases. If we try to open this up, it's going to be 72 minus what's 2 times x? That's going to be 2x minus 1,000. We're dividing it by, no, this must be plus. We're dividing it by 100. Is that true? Yes, it's true. Then if we divide that, it's going to be so 7, 2 minus, I'll say 2x over 100, I'll say x over 50 in this case, plus now 1000 divided by 100, that's going to be 10. And then 7, 2 plus 10, that's going to be 82. What happened to the x? I don't know. We shall see. 82 minus x over 50. Okay, but now all this again must be multiplied by the number or by the income that is increasing. So we get the 82x minus x squared over 50. Then 10.2, they want us to get the maximum daily income. So with maximum daily income, we have to differentiate. We need to differentiate that. So if we differentiate that, that's going to give us 82 minus x over 25. Equate this to 0. Move that aside, so x over 25 is equal to 82. Then multiply both sides by 25. So 82 times 25, getting 2050. So that is the daily income. Question 11, telling us events A and B are mutually exclusive. So mutually exclusive simply means they cannot happen at the same time together. Probability of B is twice probability of A, and probability of A or B is that calculate B. So from the addition rule, you know that probability of A plus probability of B minus probability of A and B. But for mutually exclusive, this whole part is a 0, so it doesn't count. Let's substitute A or B is 0.57 is equal to our A. Let's leave it as A. And then our B is twice A. And then 1A plus 2A's, those are 3 PA's, is equal to 0.57. So if we can find the A, which is 0.57 divided by 3, that gives me 0.19. Then we need to just substitute this to get the B, which is 2 times 0.19. And then that must give us 0.38. Okay, then 11.2, telling us a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one. What is the probability that the first calculator chosen is not defective? So 5 of the calculator are defective. So for the remaining ones that are not defective will be 40 minus 5, which is 35. Okay, we'll divide by 40. 35 divided by 40, we simplify that, can give it as a 0.875. Or you simplify and give it as a common fraction. Okay, then what is the probability that if 2 calculators are selected, one calculator is defective and the other is not? So if we were to draw just a simple tree diagram, defective, not defective, then defective and not defective, defective and not defective. Okay, so for the first part of it being defective, it will be 5 over 40. We're saying 35 over 40. And then if it was defective and then another one is defective, then it's going to be 4 over 39. And then Okay, so we have 4 plus 3, which gives us a total of 7. So 7 factorial. Just use your calculator and find that. So that's gonna be 5040. That's the answer. Then they're asking us that if two particular books must be placed next to each other, in how many different ways can you arrange the books? So if we have 1, 2, 3, 4, 5, 6, 7, they're telling us if two books can be placed together, in how many positions can we place them? So it's going to be position number 1, position number 2, position number 3, position number 4, position number 5, position number 6. So in other words, we shall have 6 different positions to place these two books. Okay. Times the arrangement of the two books, they can switch. Maybe book 1 and book 2, 2 can come first and then 1 can come next. So that's going to be 2 factorial. In how many different ways can you arrange the books and show? So 6 factorial times 2 factorial. So from my calculator, we have in 1440. Okay. Then if all the economics books must be placed next to one another, and all the life science books must be placed next to one another, in how many different ways will you be able to arrange the shelves? Now, step number 1. We have, let's see, 2, 3, 4, 5, 6, 7. We have 4 books that are going to move as a block. And I see it's just one position that we can, no, it's not one. Okay, that's 1. We can have the second one. Okay, 4. Can have this as a 4. Can have this as a 4. But will it accommodate the other ones? Because now that's one other thing that we need to bear into mind or into consideration. So I'm just going to say the 4 books and switch within themselves, because it's not only the economics books that we're focusing on. So I'm going to have 4 factorial, and then with the life sciences, which are 3, I'll also set 3 factorial, and then the 2 books can sit together, because this clearly is not going to work of the shifting. So it's only one kind of arrangement for 4, one arrangement for 3, and then the books can switch within themselves. Okay, so we're saying this is not working. It's just 4 factorial within the economics books times 3 factorial within the life science books times 2. And then when I multiply that together, I'm getting 288. Thank you very much, guys. Let's meet in paper 2.